Next up, we have Cline from KTA Tator. He's going to talk about maintaining modern bridge coating systems. So,
I'm Cline with KTA out of Pittsburgh, PA. I'm the Coatings Group Business Unit Manager, and I'm presenting today on maintaining modern bridge coating systems. Billions of dollars are spent each year in a battle against corrosion on our country's infrastructure. Choosing the most viable surface prep and coating materials for our bridges can save the DOTs and taxpayers a substantial amount of money. So I'll be presenting information today on a 20-year coating study done on the eastbound Mathis Bridge, the effect of soluble salts on steel structures in harsh environments, and a coating study being done on the Verrazano Narrows Bridge, and some key takeaways to consider when maintaining modern bridge coating systems. So there are essentially 5 options to consider for possible coating maintenance approaches. The options are in order of increasing cost and increasing benefit to the owner. Do nothing, you're deferring maintenance to a later time. There are a few variables that may warrant doing nothing. For example, the existing coating is in good condition, lack of funding, deferred to coincide with additional work, or the bridge may be a replacement candidate in the near future. Spot painting, discrete areas of rust or corrosion are prepared and coated. Zone painting, removal and replacement of aged coatings with a new system in targeted areas or zones. For example, fascia beams or beam ends at the abutments and joints. Overcoating, application of a new coating over an existing coating, usually in conjunction with spot painting. The existing coating should be adhered well in relatively good condition. Finally, removal and replacement. If the structure does contain existing lead paint, do nothing, spot and zone painting do not abate lead. Overcoating can encapsulate it. If the lead risk is an aged coating in stable condition but does not remove the lead, removal and replacement will eliminate the risks associated with lead paint. In 1986 and 1987, the New Jersey DOT applied 47 different coating systems to individual spans of the eastbound Mathis Bridge. Each system was applied to a complete span of approximately 4,000 square feet. The DOT wanted to know how these different systems were going to perform over time. 18 different coating manufacturers donated coating systems for this experimental project, and 17 of the 18 manufacturers had a rep on site to ensure that their product was being applied per requirements. Systems range from metallizing, various zinc-based systems, epoxies, aluminum epoxy urethanes, vinyls, and oleoalkyds. They were applied to varying levels of surface prep that range from an SP2 to an SP5. Visual inspections were performed in 1995 and 2007 by Pete Alt. Each span was given a rating per ASPM D610. The standard essentially gives a rust grade from 10 to 0, with 10 being no rust, 0 being above 50%. The coating system was considered a success if it displayed a rating of above 7 after 8 years and above 4 after 20 years. These systems would be considered maintenance candidates. Failure was below 7 at 8 or below 4 at 20. These systems would be considered replacements. And a premature failure was anything below 4 at 8 years would also be a replacement. So the next few slides are going to show some graphs like this. The blue diamonds represent average cost in 1986 dollars. Green represents average success rates, and yellow are average failure rates. Red represents premature failure. So as expected, the metallizing systems, they had the highest rate of success. They were about $12 more a square foot. So, hundreds of thousands of square feet on a structure, that could add up pretty quick. The zinc systems performed very well. The greatest risk was epoxy and aluminum systems. The 3-coat systems perform much better than 2- and 1-coat systems. Something of note from this graph is the 1-coat system, although more expensive than 2 and just about the same cost as 3, had the highest level of premature failure. The SP10 cleaned spans had the lowest risk of failure, and what's interesting about the findings here is SP2 and Overcoat had a higher rate of success than SP6 and a lower cost. The SP6 non-zinc 2 and 3 coat systems had a lower rate of success but similar cost to SP6 zinc. The solvent-based zinc primer with an intermediate and top coat had the highest rate of success, and the non-zinc 2 coat system had the highest risk of failure. So towards the beginning of the presentation, I talked about how do nothing, spot, and zone do not abate lead, but when considering maintenance options for the newer systems, everything's kind of back on the table. There's no push to get rid of the lead. The slide shows here the negative effect that a harsh environment can have on painted steel structure. The 4 different colors indicate 4 different coating systems. So the panels had varying degrees of surface prep before coating application. The photo on the left is after 18 months of just natural weathering, and the photo on the right is 18 months with winter salt spray. So basically what works in one area of the country is not going to work in another with a harsh environment. So soluble salt testing and remediation are vital for a successful project in these environments. And one thing to consider when testing for salts, there tends to be higher levels in the pitted areas or areas of high corrosion. So your inspectors should be performing salt testing in those areas. The structure here is the Verrazano Narrows Bridge. It's owned and maintained by the Metropolitan Transportation Authority. It connects the New York City boroughs of Staten Island and Brooklyn. The structure was recently painted with an SP18 system. For all of you out there who aren't paint nerds, an SP18 is a thorough spot cleaning with sweep blasting. So basically you're spot blasting and priming the corroded areas and then sweep blasting the good paint to remove loose material and abrade the surface for an overcoat. The SP standards were created chronologically, so SP18 is relatively new, and it was developed specifically for maintenance painting on these types of systems. Experimental testing was done on the panels as well as on the structure to determine how other surface prep and coating systems would have performed had they been applied. The results of this study help planning for future maintenance project to help kind of drive down costs while getting a desired product. There were 7 different surface prep methods that were used. They range from SP3, power tool cleaning, to an SP10 near white metal blast. The program explored the effectiveness of spot epoxy systems versus spot zinc systems. And each SP10 system received full organic zinc, full epoxy midcoat, and full urethane top coat. All of the panels were exposed to cyclical corrosion laboratory testing. So basically one cycle is a 24-hour period where the first 8 hours is a salt solution spray, second 8 hours is a humidity soak, 100% relative humidity at 49 degrees Celsius, and the final 8 hours is a humidity soak, or is a dry off period, I'm sorry. The panels are to be visually inspected after 20, 40, 60, 80, 100, and 120 cycles. The panels on this slide are the result after 40 cycles. So the corrosion, as you can see, is coming from the crevice, and no caulking was applied. For the SP3 clean panels, the epoxy is actually performing slightly better than the zinc, and SP15, they're pretty similar. Here are just a few more photos of how the zinc systems are performing against the epoxy systems. Panels on the left are SP18, panels on the right are SP10. The field test cleaning and painting on the actual structure was done in March of 21. There were 7 areas of the bridge that were prepped and coated. Each area was approximately 100 square feet and was located along the floor truss lower chords. One side was prepared per surface prep method, coated with a spot epoxy prime coat, and then the back side was prepared with a spot organic prime coat. The only exception is the SP10 clean surface was only performed on one side and received a full organic zinc primer coat. Each area also received a full epoxy intermediate, and full urethane. And the plan is to look at these test patches periodically and document the results. So there's a catwalk to give them access when they choose to do their assessments. These systems were also evaluated per ASTM D610 after 7 months, and it did not include a winter exposure. The spot organic zinc systems with SP3 and SP15 were performing slightly better than the spot epoxy systems with the same level of surface prep. As you would expect to see, SP18 and SP10 are showing no signs of corrosion after the 7 month evaluation. Here are just a couple of photos, SP10s on the top, SP18s on the bottom. The SP3 clean surface is showing some flaking on the top of the bottom flange. It's the photo on the left. The photo in the center shows some mud cracking due to, looks like, some puddling on the top of the bottom flange. And then the spot zinc SP15 seems to be performing well. We are seeing the DOT start to scope more zone painting with the existing high-performance coating systems. For the most part, they've held up pretty well with only kind of localized areas of corrosion at the abutments and joints, especially if leaking from above. Hand on the fascia girders if close to the roadway due to salt spray, vehicular salt spray. When they're replacing the coatings, we're typically seeing an SP10 with a new organic zinc epoxy urethane system applied about 5 to 10 feet from the abutments and from the joints as well. What's interesting, we've also seen some DOTs kind of where the salt spray is hitting the bottom flanges, paint the entire bottom flanges and go up 1 to 2 feet into the web. Although stone painting's a little more expensive as a cost per square foot, it's much cheaper than complete removal and replacement. So it's a fair question to ask. You know, you're already there, containment's in place, traffic control's in place, you know, everything else that goes along with the project, why not just completely remove and replace them? I think you have to consider, you know, how comfortable are you with the existing coating that you're not replacing, holding up for 15, 20 years or the next full paint. A couple of things to consider with zone painting. It's not going to be a feasible option if aesthetics are really important to you. There's going to be color variations in the spans. You can try to match the faded color, but there will be a clear difference. The transition areas of new paint to existing paint could become a problem if not done correctly. Each coat should be tied back into the existing coat. So new zinc primer tied back into the old zinc primer and intermediate as well. Well-written spec will require feathering to tie them back in. These areas should also be tested with a dull putty knife to make sure it's tightly adhered. I'll show you a repair area here in a couple of slides that show what the feathering should look like. To get a nice clean line, the contractor should be using a rubber mat or some kind of barrier at those areas. But I've also seen them kind of use a blast nozzle and just kind of blast them back towards the abutment or pier, whatever they're blasting towards. Here's a photo of what I just talked about. They didn't use a barrier there. And although this isn't a zone transition, it's a repair area. You can see the bare steel, and then you can see the zinc primer, the intermediate. So that's kind of what the feathering should look like to tie back in. So in conclusion, there are more maintenance options available for the modern systems. There's really no push to completely remove the existing coatings to get rid of the lead. The savings can be substantial, especially on the larger structures with hundreds of thousands of square feet. If total removal and replacement isn't necessary in harsh environments, soluble salt testing or remediation are vital to a successful project. You know, don't just do your testing out on a web. You know, try to get where the salts are going to hide. And finally, if there's a large amount of existing coating still in good condition, why remove and replace if not necessary? You know, we see a lot of removal and replacement projects. You're kind of scratching your head because 90 to 95% of the coatings is still in pretty good condition, and they're completely removing the coating. That's all I had.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.